Hello and welcome to another mathematics video in which we seek to analyse and solve ordinary differential equations amongst other things. Now here we have a non-linear electrical circuit as shown in the diagram. So we have a voltage source, a resistor, an inductor and the non-linear component, which is depicted by the ki cubed term here. So it's actually a cubic term, basically. So the equation on the right is the ordinary differential equation that describes this circuit. So we've got the voltage across the inductor, L di by dt. We've got the voltage across the resistor, which is IR, and we've now got a voltage of Ki cubed. And we want the total voltage to be 0. So how do we go about solving this equation? Well, first of all, we want to write L di by dt plus IR, because that's kind of linear part, and that's equal to minus Ki cubed. And then, of course, we divide by L to get di by dt on its own, plus well, in actual fact, let's put the constants first. So plus R over L times I equals minus K over L times I cubed. Right, okay. So now what we see here, as in the previous video, we have a Bernoulli equation. Right? So how do we solve this equation? Well, it's similar to what we solved in that previous video. And when I cut and paste it, we can go ahead and perform the solution. So we've got di by dt plus ri over L, which is equal to minus ki cubed over L. Make that look more like a cube term. Yeah. So what we actually, the substitution that we use as before is v equals I to the power 1 minus n. Now, from this equation, we ought to call that equation 1. We can see that n is equal to 3 in this case. It's a cubic term. That's this term here in the indices. So that substitution becomes v equals I to the 1 minus 3, which is equal to I to the minus 2. We'll just write it here more succinctly as v equals I to the minus 2. This means that dv is equal to minus 2I to the minus 3 di. So that di is equal to minus a half of I cubed times dv. We know that, well, what we want to do is we want to find out what I is equal to on its own. So from, we'll choose this term here. From this term, we have v equals 1 over I squared. So I squared equals 1 over v. So I equals 1 over v to the power of half. To square rooting both sides of this equation, we get this. So now we can determine that I cubed is equal to 1 over v to the 3 over 2. You see, we've just cubed that v to the power half so that we get v to the power 3 over 2. So we'll just return to the little line above. We have di equals minus a half I cubed dv, which is equal to minus a half over 1. Sorry, it's minus. Let's get this absolutely right. So we got minus 1 over 2v to 3 over 2 dv. So from this, I know my working is looking a bit messy, but anyway, we have di equals minus 1 over 2v to the 3 over 2 dv, and we can divide by dt on both sides to get that. Now we have more or less got the information we want, because we need this, because we're going to stick it back into equation 1 there for that term, and we also need our term for I, which we've worked out here. That's our I term, and we know that our I cube term is that. So these are the 3 pieces of information that we need to put into equation 1. So let's do that. So we get, well, I'll write this in green. So substituting di by dt equals all of this here, which I'm ringing green again, into di by dt, we get minus 1 over 2v to the power 3 over 2 dv by dt plus r over l times I, but we know that I is this term, which I'm ringing in green there as well. So we've got a v to the power a half term there, and that's equal to minus k over L times I cubed, but I cubed is 1 over v to the power 3 over 2. So I'll write it like that. Okay, right, now let's cut and paste that. Oh, by the way, we really want to give it a label. So let's go back and label that as equation 1. Actually, it's equation 2, isn't it? So equation 2, that being equation 1, and now we've got equation 2, which we've also got on this page, right? And so we can start to simplify the equation. So multiplying through by, I'll write this down, multiplying through by 2v to the power 3 over 2. But by the way, in my previous video, I got this little bit wrong that I'm writing here for that particular question. I said you multiply through by 1 over v squared or something like that. It should have been multiplying through by v squared. But that was just something that I got wrong at the time and I didn't notice it. But in this particular case, we're multiplying through both sides by 2v to the power 3 over 2. And that's because, if you think about it, we want to reduce this coefficient to just 1, and then the equation is easier to work with. And in actual fact, we're going to multiply through by minus 2v to the power 3 over 2 because we want the coefficient of plus 1 here. We want that to be plus 1. So if we do that, multiply through both sides by 2v to the minus 2v to the power 3 over 2, then we get and how shall I write it down? Yeah, so I'll write it in full here. Minus 2v to the power 3 over 2 times minus 1 over 2v to the power 3 over 2 dv by dt plus r over L. Oh, and there's a v to the power half there. And then we're doing the same on the other side. So we're multiplying by minus 2v to the 3 over 2. Right, okay. I won't label that equation as yet. But what we get, let's turn to blue. So this term multiplied by this term cancels to give, well, we just get dv by dt. And then we get a minus, because this minus 2v to the power 3 over 2 multiplied by the plus r over L v to the power half becomes minus r over L v to the 3 over 2. And I'm going to write this v to the power half there as v to the power minus a half on top. And that's equal to minus k over L, and, well, straight away you can see that that cancels with that. Right, so we're left with, oh, and we've actually got a plus term there, haven't we? Because what we've got is this minus term times this minus term, which is just plus. So we don't need to write the plus in. We've got a factor of 2 times k over L. So we've got that. Now we will call this equation equation 3. And I'm going to cut and paste that again. Right. And so we've got an equation that can be simplified there to give, so we'll write down simplifying my P's aren't looking, that is absolutely awful writing, but never mind, hopefully you can understand it. So simplifying equation 3, we have dv by dt minus r over L. Well, what's 1.5 minus a half? Well, it's just 1, isn't it? So it's v to the power 1, or just v. And that's equal to 2k over L. So now we've got equation 4. Right, we need an integrating factor. So an integrating factor, we'll do this in green, is e to the minus r over L times the integral of dt, which is equal to e to the minus r over L times t. So multiplying both sides of equation 4 by e to the minus RL, multiplying both sides of equation 4 by e to the minus r over L times t, we get the following. Minus r over L v, and then we'll just write the e to the minus r over L t there, and then that's equal to 2k over L times e to the minus r over L t, and we'll call that equation 5. And once again, I'm going to cut and paste it. So it doesn't matter if we cut that off. There we are. Okay. So now the left-hand side can simply be written as d by dt d by dt of, in brackets, e to the minus r over L t, and then we want this v term here, and that's equal to 2k over L e to the minus r over L t there. We'll call that equation 6. So integrating both sides, we get, I'm going to write it here to save space. So we get e to the minus r over L t times v equal to 2k over L, and then we integrate e to the minus r over Lt term, so we get a minus r over L term there, times e to the minus r over Lt plus a constant c. And there we are. So this gives e to the minus r over Lt v equal to, well, what's 2k over L all divided by minus r over L? Well, we can just work that out down here. 2k over L divided by r over L, and we've got the minus sign there, which we mustn't forget. This is the same as writing minus 2k over L times L over r, and that's equal to 2k, or rather minus 2k over r. Okay, so we've got minus 2k over r times e to the minus r over L times t plus c. And we will just erase this here and for a bit of space, and we'll call that equation 7. Right. And I'm going to have to cut and paste again. Right, okay. So you just have to ignore that there. That's not part of the equation. That's from the line above, as you should remember. Now, this can be rewritten. So dividing both sides of 7 by e to the minus r over Lt, we get v equals minus 2k over R plus C over e to the minus R over LT. But that's just the same as writing C e to the R over LT. Now, we're almost finished. That's equation 8. We need to know what V is. Well, let's go back and find out what we substituted to bring about V. So if we go right back to here, we haven't used blue ink here, have we? So we deduced that V was equal to 1 over I squared. V is equal to 1 over I squared. So we'll put now V is equal to 1 over I squared, which implies that I squared is equal to 1 over V. So what we have is, and let's go back to black, we have I squared equals, and I think we'll have to get rid of the stylus there, is equal to 1 over, I'm going to write the expression like this, CE to the R over LT minus 2K over R. And before I do anything else, I'm going to multiply top and bottom of this equation by R to get R divided by CR e to the R over LT minus 2K. Right? Now we're almost finished. Let's bring back the stylus and cut and paste all of that up there so that we'll just write it here. I squared equals R over CR e to the R over L times T minus 2K. So therefore, I is equal to the square root of R divided by CR e to the R over LT minus 2K. And you could write that as R to the power a half, all divided by the square root of CR e to the R over LT minus 2K. And we want to give the equation a label. So that was equation 9. That's the same equation, equation 9. And so this is equation 10. And this is the solution to what was the original equation? Let me see. Is this the one? Yeah. So that was a solution to di by dt plus RL R over L times I equals minus K over L times I cubed. I don't know if I can remember that to write it all down again, but that was a solution to di by dt. t. Let me just go back. Ah, there we are. di by dt plus ri over L plus ri over L, and that was equal to, my memory is not good at all, minus ki cubed over L. Might remember it that way. Minus ki cubed over L. So that is basically that. We've formed an equation, di by dt plus ri over L, which is equal to minus ki cubed over L, and we've then solved it to get this solution for I. And again, that, as they say, is that. And I hope you've learnt something from this session and that you will come back for more. And until then, I'll bid you farewell for now and say goodbye. So see you soon. Okay, bye.